So we're going to start here by looking at rearranging formula again. So we're going to look here at this one here because we're dealing with fractions, and it's good to have an example of how to rearrange formula when you're dealing with fractions. The question asked to rearrange, I'm going to the number 3 here first. It asks us to rearrange it and to make x the subject. Okay, so that means that we need x by itself equals, and it doesn't matter what it's equal to as long as it's x equals whatever. Okay, for the second one there, they want b to be the subject. So these dots and the x in the brackets just means that they want x to be the subject. So we'll start off like we always do, just by writing out the question. So the question is 2x, okay, 2x minus 1/3 equals y over 3. Okay, and like I've been doing in the previous questions, I'm going to put x in there in pink because that's the one that we're looking for, right? Okay, so you can see from that, if I'm looking to get x by itself, I'm just going to do it step by step. I need to get this term here by itself. So in order to get this term by itself, I need to get rid of everything that's attached to it. So I need to get rid of this here, which is your negative 1/3. So in order to get rid of that negative 1/3, I can take that negative 1/3, okay, and I can bring it to the opposite side, and then I'm on track to get this. I have to get x by itself. Okay, so that will leave me with the following. So that will leave me with 2x, 2, and obviously x there is in pink, is equal to y over 3. And instead of being minus 1/3, I'm going to add 1/3. And the reason why I'm adding 1/3 is because it's coming across the equal sign. So it was a negative third, it comes across the equal sign, so it turns into a positive third. Okay. The next step there, like I always say, when you fractions, if you have two fractions, you want to turn it into one, because it's easier to deal with one fraction than it is to deal with two. So those two fractions there, when I have two fractions, I'm going to turn that into one fraction. And this one's quite straightforward because those two fractions have the same denominator. And you know we can add fractions if they have the same denominator. So I'm going to say 2x in this case is equal to, and I'm going to pull the two of them together, and it'll be y plus 1. Okay. So the next step there is to get x by itself, right? So in order to get x by itself, I need to look at what I'm doing to x, and I'll just highlight that so you can see. I want x by itself, and that's what I'm going to get, so I'm going to put that down here. And that's going to be equal to, okay, and what I need to do now is I need to see what I was doing here. So back here, what I was doing was I was timesing x by 2, okay? So to get rid of this times by 2, I need to divide the left-hand side by 2. So if I divide this side by 2, I'll be left with just x, okay? And that's exactly what I want. I want x equals. That's what we were asked to do in the question. So the left-hand side is sorted, because if I divide this by 2, I'll be left with this. But I need to do the same to the right-hand side. So I need to divide this side by 2. And I'm just going to put that in small blue writing there because it's important that you can see what's actually happening. So going from here to here, I'm dividing by 2. So I have to do the same at this side and divide this side by 2. Now, because we're dealing with algebra, people are going to think this is more difficult than it is. So I'm just going to show you there as an explanation. If we had a fraction, say we had 1/2. If we divided 1/2 by 2, we would end up with 1/4. And we know that from number sense. We know that from dealing with numbers. So if we divide a half into 2 equal parts, we'll have 1/4. Okay. If we had, we'll say 1/10. If we, or 1/6 even. If we had 1/6 and we divided that into 2 equal parts, think about it. You have 1/6. So this is your 1 unit would be the full way across. If we had 6, then we'd have 1, 2, 3, 4, 5, 6. So this is 1 unit. Obviously, this is 1/6 and 1/6 and 1/6 and so on. So if we took 1/6 and we divided it in half, we'd end up with 1/12. Okay, so you know all this from primary school. Okay, so that's what we're we're constantly trying to link in with what we already know. And we already know this from primary school, that this would be equal to 1/12. But we need to make a conclusion here. So let's just see if we had 1/10. And if we divided 1/10 by 2, so if we had 1/10, if we had 10 of them there and we divided it, so you had 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you had 10 equal parts here, and we divided it by 2, we have 1/20. So you already know all this, okay? But what you need to understand is what you're actually doing. And what you're actually doing is you're timesing your denominator by 2. Okay? So when we divide by 2, what we're effectively doing is we're timesing our denominator by 2. So for the first question there, our answer will be y plus 1 all over 6. Because when we divide a fraction by a number, we just multiply the denominator. So what we actually do is when we divide this by 2, it's the same as multiplying it by 1 over 2. Okay? So that's just working with fractions. And I'm going to just take all this and bring it out because we won't need this again. So I'm just going to take that out for now and get it out of the way for now. Okay, so we can refer back to that if we need to. Okay, so we move on there to the next one, and you'll see there what I'm after doing. I'm just after bringing in a question there, which we look at after we do question 6. So we're going to do question 6 first, and then we look at question 5. So for question 6, it asks you to get b as the denominator. So we're just going to write out that question, and then we'll highlight what we're looking for. So a is equal to b over 2, b all over 2, minus 3c all over 4. So you can see there what I'm looking to get is I'm looking to get b by itself. Okay. So first thing we need to do, like we always do, is we need to look at what we're looking at. We're looking at getting b by itself. So we need to attach or get rid of everything that's not attached to the b. So in this case, this is going to stay here, but I can get rid of all of this. Okay. So it's important that we do this bit by bit. So I'm going to bring all that over to this side, and that will leave the b's over on the right hand side by themselves. So I'll have b over 2 is equal to a, and in this case I'm going to add 3c all over 4. So because it's moving across the equal sign, it changes from a negative to a positive. Okay. The next step there is to simplify that, and to simplify that again, I'm going to look at this here, right? So there's 2 ways we could do this. We could multiply across by 2, but I think it's easier if we turn this into a single fraction. And if we turn that into a single fraction, it makes it easier to work with. So I'm going to turn that into a single fraction. And how I'm going to do that is I'm going to say a is the same as a over 1 plus 3c over 4 equals b over 2. Now, it's important for you to realize that there is different ways of doing these. I think this is the easiest way in terms of explaining it, so that's the way I'm going to do it. So, from what we know of fractions, if I want to turn this into a single fraction, then I need to get a common denominator. So the common denominator for this is going to be 4, and we know that from working with algebraic fractions. So the common denominator is going to be 4, so I'm going to make a denominator of 4 plus a denominator of 4 equals b over 2. Okay, and how I did that was I scaled up this by 4. So I had to multiply the denominator there by 4 to turn it into 4. Okay, so to turn 1 into 4, I had to times the denominator by 4. But like, because it's a fraction, if I scale up the denominator, that's fine, provided I scale up the numerator. So I'm going to scale up that numerator there, and it'll give me 4a. Plus, this already has a denominator of 4, so I'm going to keep that as 3c on top. And now I have two fractions with the same denominator, so I can pull those two fractions together and give my denominator a 4, and I get 4a plus 3c is equal to b over 2. Okay, so that brings us to the next stage, we can say. So at the minute we have two fractions equal to each other. Anytime we have two fractions equal to each other, we need to be able to cross multiply. So what I'm going to do is I'm just going to bring this up to make a bit of room, and I'll cross multiply there then. Okay, so just bear with me. So here we have our fraction equals a fraction. So in order to solve a fraction equals a fraction, we can cross multiply. So I'm going to multiply the numerator, the denominator on my first fraction by the numerator on my second, and the numerator on my first fraction by the denominator on my second. Now, it doesn't matter which way we put them, as long as the equal sign stays in the middle. Typically, when I cross multiply, I try and keep, if I'm trying to get a value for b, I want to keep the b's on the left-hand side. So when I cross multiply here, I'll say 4b is equal to 2 times, and this will be 4a plus 3c. Okay. If I expand that, I get 4b is equal to 8a plus 6c. All I've done is multiply this by this to get 8a, multiply this by this to get 6c. So my final answer there, to get b by itself, I need to divide both sides by 4. So b will be equal to 8a plus 6c all over 4. Now, depending on what way you give your answer, it's most likely that they probably would have simplified that and divided everything by 2. And you could divide everything there by 2 and say that b, okay, so let's just get this out of the way. You could have said that b was equal to, in this case, b was equal to, if you divide the top by 2, you'd get 4a plus 3c all over 2. So what I did there was I divided my numerator, divide everything there by 2, and you get 4a plus 3c, 4a plus 3c. But if I divide everything on the top by 2, I have to divide everything on the bottom by 2, and 4 divided by 2 leaves with an answer of 2. So that's those two questions there. I just highlight the two of them as answers so that you can see that they're the same question. And that's not the next question. Okay, and I'll just put or there. Okay, so that's that one. So that brings us on to the next one, which is just there. And we'll start that question now. So in this question, this comes back to what we were doing with solving algebraic fractions in the earlier lessons. So if we want to solve this, we'll just write it out first of all and just see what's happening. X is equal to y minus 2z all over 3. Okay, so, and again, I'll just highlight the z because the z is what we're looking for. So we want to get z by itself. Just while I'm doing this, just while you're watching in, the reason when I write z's, and you'll see that a lot of science and maths teachers tend to put a line through the middle of that. The reason why I put a line through the middle of it is because anytime I write z, just to make sure I don't confuse it with the number 2, I normally put a line through it. So it's a common thing that you'd see people that are working in maths tend to draw their z's as 2 with a line through it, right? So in this case, I need to get z by itself. So what I need to do is, first thing I need to do is I need to see what's attached to z. So how can I break this up? So I can get this by itself, first of all. If I can get that by itself, I can turn it into a linear equation. So I can get rid of that fraction, and then I'd have a linear equation, and then it's very, very easy to solve. So in order to get rid of that fraction, what I need to do is I need to times both sides by the denominator. And we did this before. Anytime you want to get rid of a fraction, you just times both sides by the denominator of that fraction. So if I times both sides by 3, I'll end up with 3x equals y minus 2z. Okay. From there, there's no challenge. So from there, you should be able to work the rest out. So if we want to work the rest out, we want to get z by itself. So we need to get rid of this y, and we'll bring it over to the other side. And that will leave us with 3x minus y, obviously, because it's coming across, equals minus 2z. Okay. Again, we're looking at what our goal is. Our goal is to get z by itself. So if I want z by itself, I need to see what I'm doing to z. And what I'm doing to z there currently is I'm timesing it by negative 2. So you can see here that I'm timesing z by negative 2. So to get rid of that, what I need to do is I need to divide the right-hand side by negative 2 to get z by itself. And if I want z by itself, if I divide the right-hand side by negative 2, that's fine, but I need to do the same to the left-hand side. So I need to divide the left-hand side. So I need to divide 3x minus y. I need to divide that by negative 2. So that would be my final answer. But a lot of the time, we tend not to like having a negative in our denominator. So this fraction here, okay. So I'll just highlight that because that is the answer. But I'm just going to show you how we can get variations of that answer. And for those of you that are doing quite well in maths, you'll find this, it's good for you to see this. For those of you that are finding this difficult, if you got that far, that's brilliant. Okay, so different variations of this would be, we tend not to like to have a negative in our denominator. So I'm going to transfer that negative to my numerator. So just before I do that, I'm just going to show you a couple of things. So negative 1 over 4 is equal to 1 over negative 4, and that's equal to negative 1 over 4. So what I'm trying to get you to understand here is it doesn't matter when you have a negative fraction, it doesn't matter if the negative is associated with the numerator, with the denominator, or if it's just put beside the whole thing. So it doesn't matter. The negative is just, in this case, which we would think that the negative is associated with the denominator, but it doesn't matter. So what I'm going to do is I'm going to change this, and I'm going to bring that negative up to my numerator and keep this positive. Okay, so that's just for understanding down here. So I'm just going to leave that there, and I'm just going to show you what I mean. So what I'm going to do, like this here, it doesn't matter if the negative is associated with the denominator or with the numerator, okay, because it's the same thing. So currently my fraction looks like this, with my negative associated with my denominator. I'm going to change that so that it's like this. So I'm going to bring that negative from the bottom and bring it up to the top. But in order to do that, I'm just going to draw that fraction out again, equals z. So in order to do that, I'm going to turn my denominator into a positive, and then I'm going to have to change everything on my numerator. So that'll turn into a minus 3x, and if I'm multiplying everything on the top by a negative 1, that will turn into a plus y. Okay, so the final answer there that I would expect to see if this was on a junior cert exam, I would expect to see the positive y, the minus 3x all over 2 is equal to z. So that's the various different variations of that answer that we can get. Okay, so all of these answers would be correct. But it's just to get you to realize that they all have the same value. It's just that I'm moving the negative from the denominator to the numerator. Okay. And just so that we're not confused, I'll just take that out of there. Okay.